So in our second video on rounding, we're going to be looking at decimal places, truncating, and using your calculator to fix all your answers to decimal places. We'll also look at the method behind rounding to decimal places, and also look at error bounds when you're asked this particular aspect on rounding in questions either on your classwork, homework, or in an exam. So in our second video, we're going to be focusing on rounding to decimal places, fixing your calculator, and truncating. Now, rounding to decimal places is used for numbers involving digits after the decimal point only. So, for example, we can round numbers like 12.344 and 0.23455 because they've got digits after the decimal point. For numbers like 1230 or 23, which have got no numbers after the decimal point, this method of rounding becomes a bit obsolete, it becomes a bit pointless. So, we can only use rounding to decimal places if you've got digits that follow the decimal point. So for example, we've got 12.84933. So as this has got 5 numbers after the decimal point, we can say that this number is written to 5 decimal places. And note that we don't know whether this number has been rounded to 5 decimal places, but we know that it has got 5 numbers after the decimal point, so we can say it's been written to 5 dp. Likewise, for the second one, we've got 12.08, so as we've got 2 numbers after the decimal point, we can say it's been written to 2 decimal places. And for 2.3048484, as this has got 7 digits after the decimal point, we can say that it's written to 7 decimal places. Now, it's really, really important that you get an understanding of what these questions in maths actually are looking for you to find. So it's having an idea of what your answer should actually look like. So if a question is asking you to round numbers up to 3 decimal places, then basically all you're wanting is 3 numbers after the decimal point compared to the original number, which is obviously going to have more than 3. Now, in terms of method of rounding, now this is not fixed in stone. There are several ways in which you can do this, but I would say as a way of understanding, having a set structure to how to answer these questions certainly makes sense. Now, it might seem that you've got a lot to remember on the screen, but trust me that when you've mastered this skill, you'll be able to do these in your head like a Jedi. So, let's get started. So on this particular question, we've got the number of 12.47834, which has got 5 numbers written to 5 decimal places, but I want this number written to 2 decimal places. Now, what does that mean? Well, it means I only want 2 digits after the decimal point. So that's what our end game is going to be. So as you can see, it's written to 5 dp. I want this written to only 2 dp. So looking through this method, so the first step we need to do is if I write this question out again, seeing as I've already kind of graffitied over the question. So here we've got 12.47834. Now I'm going to underline the required numbers of numbers I need for this rounding sort of stipulation. So here I'm going to round this number to 2 decimal places. So what I'm going to do is I'm going to round this number up, underline the first 2 numbers after the decimal point. Now then the second step is that I need to circle the digit after the underlined number. Now I've underlined 47, so the next digit is 8. Now the third step, which is probably the most important, then asks you, is the circle number bigger than 4 or is it 4 or less? Now as the circle number is 8, what I'm going to do is add 1 to the underlying number. So 1 plus 47 is going to be 48. So the final answer is going to be 12.48. And then after the fourth step is basically ignore any other digits after the underlying number, in which the final answer then is just 12.48. Now let's say I'm going to change this question. Let's say we're going to round 12.47834 to 3 decimal places. So for this, what I'm going to do is I write the number out. Again, you could just look at it. I'm going to underline the first 3 numbers after the decimal point, which is 478, and I'm going to circle the digit after the underlined number. So not 34, just the 3. And then I'm going to check to see, well, is my circle number bigger than 4 or is it 4 or less? Now in this case, it's 4 or less. So then I'm not going to subtract 1, which seems the most logical thing to do. The number stays the same. So what the actual answer to 3 decimal place is going to be is 12.478, and there is your final answer. So depending on the number of decimal places, it might give you different answers. So it's always important to check and read the questions carefully and whatever requirement of rounding they are wanting. So let's have a look at some more examples. Now, if you want to pause the video and have a go at these questions yourself, by all means go for it. Or if you want to just listen to me going through the answers, that's entirely up to you, whatever floats your boat. So for question number 2, I'll try and colour code these. So for number 2, I've got 34.6823. Now, because I want to round this number up to 2 decimal places, now what I'm saying is what you should be thinking. So here, 2 decimal places, underline the first 2 numbers after the decimal point. Circle the digit after it. Now, as the circle number is less than 4 or 4 or less, the underlying number stays the same. So the actual answer is 34.68. For question number 3, let's do this in red. So I've got 134.70673. Now for this I want 3 decimal places, so I underline the first 3 numbers after my decimal point and I circle the digit after it. I then check, is the circle number 4 or bigger? Bigger than 4? Yes it is, so I'm going to add 1 to 706, giving me 134.707. For question number 4, so let's do this in green. I've got 0.03744. Now even though I've got a 0, so here I want this to 4 decimal places, so even though I have got a 0, I'm going to include that as a digit. So underline the first 4 digits after the decimal point and circle the 5th. Now for this, the underlying number is 374. So as 4 is 4 or less, I'm going to leave the underlying number as it is, giving me a final answer of 0.0374. And then for question 5, let's do for purple, so we've got 63.786733. And we'll round this up to 1 decimal place. So I underline the first number, circle the next digit. As 8 is bigger than 4, I'm going to add 1 to the 7, giving me 63.8 as my final answer. For number 6, now it is possible for you to be asked to write numbers to 0 decimal places. So here I've got 2.5. Now to 0 decimal places, I'm going to underline the number before the decimal place. So here I've underlined the 2 and I'm going to circle the 5. Now as the circle number is bigger than 4, I'm going to add 1 to the underlying number, giving me an answer of 3. Now because the question's asked me for no decimal places, I'm not going to write this as 3.0, I'm just going to leave this answer as 3, which kind of leads me into number 7. Now with number 7, if I write 23.9876, so this I'm going to underline the 9 and circle the 8. Now the problem I've got here is, yes 8 is bigger than 4, so technically what I'm going to do is add 1 to the 9. Now this is where the most common mistake comes in, is they think, right, well okay, well I need to add 1 to 9, and 9 plus 1 is 10, so the answer then is 23.10. Now there's a couple of problems with this, is one, I don't have 1 digit after the decimal place, although we've got a 0, it still counts as a digit, but also 23.1 is quite a long way off from 23.9876, so there's definitely an error here. Now in theory what we're trying to do is to 1 decimal place I've got 23.9 and the next 1 decimal place is 24. Now I need to decide, well whereabouts is this 23.9876? So I need to decide, is it closer to 23.9 or is it closer to 24.0? Now 23.1 is going to be way over here, let's say, in which that number is going to be nowhere near this range of numbers that where the answer is going to be. So your answers are either going to be this or 24.0. Now for this, what we need to do is, rather than add 1 to the underlying number, I'm going to take it to the next digit. Because it's 10, I need to carry the 1 over to the side, which means that the correct answer to question 7 is going to be 24.0. Now, do I need to include the 0.0? Well, yeah, because the question's asked you to 1 decimal place, so you should have a digit after the decimal point. But however, if you were to write 24, I would still give you the mark for that. But I would say it's good practice for you to write the 0.0. Now, as I mentioned, that rounding is a very, very much cross sort of topic question, and it's really it's valuable And I can't stress that enough of how your ability to round numbers is going to be important, because it kind of gives you that final mark in those big mark questions that you might get in an exam. So in this particular question, it's asking us to use a calculator, and whatever the answer gives us on a calculator, we need to round that number up to 2 decimal places. Now, I need to make sure that when I'm doing any calculator work, that how the question is written on the question paper is exactly what it looks like on my calculator screen. So now what I'm going to do is enter these calculators. I've got 4.56 times 12.547 to the power of 3. And if I scroll across to the denominator, I'm going to enter 67.2458. Now, just before I press the equal screen button, I should say, I'm going to just double check to make sure that my calculator looks exactly what the question does, and I'm pretty confident that it does. I press equals and I get 1.411325,225. Now, as you can see, that is a long decimal number to the point where it's given me to 8 decimal places. If my eyes have not deceived me, yes they have, because it's actually to 9 decimal places. And I only want this number up to 2 decimal places. So if I start by writing this number out on the screen, so the calculator is now inconveniently going to disappear. 225, I think it was. So again, I'm going to underline the first 2 digits, which is 41, and circle the next digit. That circle number is less than 4 or 4 or less, so the underlying number stays the same. So the final answer I'm going to write down is 1.41. So that's just an example of where it can be used in other questions. Now the next thing we then move on to is error bounds in rounding to decimal places. Now this is kind of a bit of a step up, so when you go through rounding, you probably may not focus on error bounds, but it's still something that you need to look into. Now you've done this subconsciously, so you've done this without actually thinking about it, but it's important you understand the whole concept of rounding. So as an example, let's say that 3.7 has been rounded to 1 decimal place and we've been asked to find the error bound. Now what the error bound is asking us are, what is the range of numbers could you have where when you round it to 1 decimal place, the answer is going to be 3.7. So if we look at getting a colour, so let's go for A. So if I imagine I've got a scale and I've got 3.6, I've got 3.7 and I've got 3.8. Now the reason why I'm using it to 0.6 or 0.7, 0.8 is because it's asked me to 1 decimal place, and that's why I've only got a scale of where I'm only looking at tenths rather than anything in more detail. Now what this question is asking me is, under what range of values that when you round this up to the nearest is it going to give you the answer of 3.7. So anything in this region here, when you round it to 1 decimal place, is going to give you an answer of 3.7. Now the error bound is basically asking you for the lower value, what this number is and what this number is. Now in mathematics we're going to use inequalities. So to use inequalities, what this is going to be, so I enter the smallest number, which is going to be 3.65. And if I just write n or x, I'm going to go for n, and I've got 3.75. Now as you can see, the 2 numbers I've written here are what these 2 numbers here are going to be. Now the problem with rounding is that if I had, let's say, 3.8, then 3.8 would be between 3.8 and 3.9 and 3.7, and this number here would be 3.75. But the problem is that this is also going to be used in the number before it. Now this is where inequalities comes in handy. Now when a number ends in a 5, because 5 is bigger than 4, then it automatically rounds up, so it's going to be 3.8. So for this, for 3.65, if I do end up with 3.65, then this number is going to become 3.7, so that's fine. So I can have 3.65. However, for 3.75, it can't actually equal 3.75. So in theory, it should be 3.74 and then 9999999 recurring, because when I do this, because the circle number is 4 or less, that this underlying number doesn't change. Whereas if I had 3.75, then if I do this, then because the circle number is bigger than 4, that then becomes 3.8. Now again, that sounds very, very complicated, and speaking out loud I've kind of confused myself, and hope that I've kind of made a bit of sense. So for this, what we need to do is use the inequality signs of more equal to or less or equal to. So your final answer would look like this, where your first inequality sign has got a line underneath it, so it can be less or equal to, whereas the second one hasn't got an underlying number, because technically that 3.75 belongs to 3.8. Now for B, let's have a look at B. So here we've got 23.45. So again, if I draw my scale of 23.44, we've got 23.45 and 23.46. So I'm looking for this number here, this number here. So this number here is going to be 23.445. This number here is going to be 23.455. So taking these two numbers and putting it into this form, I get the answer of 23.455. And again, it could be any letter, it could be X, and 23.455. Now note that the first inequality can equal, the second inequality can't. So that is your answer for B. And then for C, let's do it in a different colour because I feel as if I've gone all over the shop. So for C, I've got 2. So again, if I do my scale, I've got 1, 2, and 3. Now if you take the first number being the middle number, so 2 is going to go in the middle, and I've got 1 and 3. So I'm looking for this number here and that number there, which gives me 1.5 and 2.5. And there is your final answer for that. Yeah, so the error bounds is basically talking about the numbers of which the final answer could be. If the number was extended to, let's say, 10 decimal places or 20 decimal places or an infinite number of decimal places, and that's what it's looking for. So moving on to the next step is how to fix your calculator so it automatically rounds numbers and answers for you. Now, this is something that I strongly wouldn't recommend that you do, because it's very time consuming, and also that in a test or an exam, your question might be a one-off rounding question. This is useful if your teacher has given you a worksheet of, let's say, 50 questions to you to work out, and for every one of those 50 questions, you need to write your final answer to 1 decimal place. So to do this, what we need to do is, so if I just reset the calculator, now hopefully your calculator resembles something like this Casio on the screen. So if you press Shift and Mode Setup, you come up to this option. Now the option we want is the one that says Fix. So if I press option 6, now then it asks me to what number do I want between 0 and 9. Now what Fix 0 to 9 is asking is how many decimal places do you want your answers or numbers to be given to. So let's say I want it to 1 decimal place. So then what I'm going to do is I'm going to fix it to 1. Now any number I type in, so if I do 23.4789650 and I press equals, it's automatically going to round the answer up. So if I do 6.2145, now I'll round up to 1 decimal place, press equals, I press the SD button, it's automatically rounded that number up for me to 1 decimal place. If I wanted it 2 decimal places, all I need to do is press Shift, Mode, option 6 for Fix, 2, and if I press SD this time, again it's rounded the number up to 2 decimal places automatically for me. And the same thing applies if you're doing a calculation. So let's say I'm doing 65.2387 times 8.9 squared, press equals, it's automatically rounded the number up to 2 decimal places. And again, if I wanted to change that to 3 decimal places, press Shift Mode, option 6, 3 decimal places, and it's giving me the answer to 3 decimal places. Now to reset your calculator, what you need to do is press Shift, Mode, and then select Norm, so option 8, and then it's always number 1. And then what that does is it will just bring your calculator back to reality and just giving you a really long decimal number. So that's how you can do it. And like I said, I wouldn't recommend it. I only recommend doing this if 1, you're not so great at rounding to decimal places, and 2, if you've got a load of questions that require you to round all your answers to 1 decimal place, then there you go. But it's always important that you do reset your calculator at the end, because like I said, you might move on to another question where it asks you to 3 decimal places, but you can't do that on there because your calculator's rigged to another decimal placing. So moving on from that, the next thing we then move on to is what's been reintroduced to the curriculum, which is truncating. Now, when I first started treating truncating, it's kind of the mistakes that a lot of students were making when they were rounding to decimal placing. Now, it's really important that, as you can see from the questions that are written on your screen, how the questions are written are very, very similar to rounding to decimal places. However, the most important word that we need to spot is this word truncate. Now, truncating is, imagine that you've got Tipex. Now, if I start off with the first question, which is A, and I've got 23.4566. Now, I want this number, so I've only got one number after the decimal point. So what I'm going to do is basically ignore all the other numbers after the first number. So the answer to this particular question of truncating 23.4566 to 1 dp is simply going to be 23.4. And likewise for B, I've got 0.2355, and I want to truncate this number to 2 decimal places. So all I need to do is just ignore any number after the second decimal place number, which in this case is the 100th. So then the answer would just be 0.23. Now for C, this is again asking for the error bound. Now the error bound for this is going to be slightly different. We're no longer looking at the scale of 23.3, 23.4 and 23.5 because we're truncating. So here, rather than our bound being there, instead our bound is going to be here. So truncating our values here is going to basically, the error bound is going to be 23.4, which is the smallest number it could be, and it can equal that number, and the biggest number it's going to be is 23.5. Now 23.5 is generally 23.4999, carry on, but we round it up to this, and the reason why we get away with this is because it can't equal 23.5. It's got to be a number that's less than 23.5. So this here is our error bound. So it's really, really important you read questions carefully, look out for the word truncate, and if you do, that is basically what it means. It's just a case of eliminating any numbers after that point. It's like basic, what you'd think rounding to decimal placing is without looking at the next digit after.